So to help prepare us to simplify our fractions in the coming unit, we're going to practice on finding greatest common factors. And it is the biggest factor. Factors are numbers that multiply to another number that are in common. So we're going to do it two ways. We're going to do it hey, here's a number, or here's our two numbers, list out all the factors of that number, and then find what the biggest one that's in common. That's way number one. Or we're going to use those prime factor trees that we talked about in the last video, or you may have didn't watch how to do it, but did it on your worksheet packet. So we're just going to go straight off the top with the first one. If we do finding the greatest common factor of 14 and 21, and yes, I understand that for some of you, bam, you already know it. Perf, that's okay. For those who don't, that's why we're here. So 14, my factors for 14 are 1, 2, 3 does not go into it. 4 plus 1 is 5. I subtracted in my head. Is 5. 5 isn't divisible by 3. 4 does not divide into it. 5 does not divide into it. 6 doesn't go into it. So our next one is 7. And then since we're already at the even, because it's 2 times 7, that gives me 14. My next one is 14. If you did not know that, when you hit that middle number where it's those two numbers that multiply to get it, everything after that, if you're putting them in the order, will be whatever the multiple is. The pairs. Okay. So that was for 14. For 21, we've got 1, 3, because 2 plus 1 is 3. 3 is divisible by 3. 4 does not go into it because it's not even. 5 doesn't go into it because it's not a 0 or a 5. 6 doesn't go into it because it's not even. It's divisible by 3, but it's not even. 7 goes into it. So again, 3 and 7 are here. So then I can go ahead and say, okay, well, 1 and 21. Okay, now I just look what's the biggest number that they have in common, and the answer to that is 7. So our greatest common factor is 7. And that's one way of doing it. And you're like, well, yeah, Mrs. Cartwright, there weren't very many numbers. That was fairly easy. You're right. You're not wrong. There wasn't. We could do something like 36 and 27, right? 36 is going to be 1, and let's just say if this list going this way is hard for you to do it in order, do it with its pairs. 1 and 36. 2 goes in, what that would be, 1. We got 1 carried, so 16, 18 times. 3 plus 6 is 9, so 3 divides into it 12 times. 4 goes into it 9 times. 5 does not divide into it. 6 goes into it 6 times, so we're just going to write it as 6. 7 doesn't go into it. 8 does not divide into it. 9 we already have, so now we're just going back the other direction. So we found all of our numbers there, so then I can do it with 27. So I know it's 1 and 27. Not even, so 2 doesn't go into it. 7 plus 2 is 9, so 3 goes into it 9 times. It's not even, so 4, 6, 8, those are all out, and 7 doesn't go into it. So those are my 4 numbers. From here, if we don't put them in order, which again, you don't have to, it just makes it a little bit harder to see, right? But we do have in common a 3, and of course the 1s. But our kicker, and the one that it is the 9. And so we find our 9. And so greatest common factor is 9. And that's one way of doing it, listing out all the factors and going, yes, that is the biggest one that goes into both 36 and 27. Now, you can use a factor tree. And so we can do like we'll find the greatest common factor. What is the greatest common factor of 180 and 54, right? So what I'm going to do, I'm actually going to space this out a little bit more. Oops. And then I've got 8 on the brain, 54. So what I'm going to do is I'm going to create those prime factor trees. So 180, I know 18 and 10, right? And then 18 is 2 and 9 is 3 and 3. Then I'm going to come over to the 10, and I've got 2 and 5. So then what I'm going to do from here is I'm just going to write this. I'm going to list them all out. I'm not going to do the exponents. So I've got 2 times 2 times 3 times 3 times 5. Okay, just good to have it there. For 54, I know that 9 and 6 go into 54. And 9 is 3 and 3, and 6 is 3 and 2. So then, I've got all primes now, so my prime factorization is 2 times 3 times 3 times 3. From here, I just got to match it up, right? I've got 1, 2, and 1, 2, and I've got 1, 2, 3s, 1, 2, 3. So then, once I have that paired up, I'm going to do 2 times 3 times 3, which I'm going to do 2 times 9, which is 18. So the biggest number that goes into both 180 and 54 is 18. And all I had to do was know my basic multiplication and division facts. I didn't have to sit there and list all the numbers that go into 180 and 54. I just had to find that prime factorization and then pair up the numbers in the end. And you're like, Mrs. Cartwright, that is not enough. I need one more. Perf, got it. Okay, I'm going to go with another 2 pretty big set of numbers. So, hey, take it back. All right, so greatest common factor of 100 and 250. So 100, I'm going to go with 10 times 10, right? And then I know that these are 2 and 5, both of them. So now my prime factors are 2 times 2 times 5 times 5. Do you have to write them out, or can you just leave them like this? The answer is yes. Either way. All right, 250. I know that that is 25 and 10 because it ends in a 0, so it's divisible by 10. So 25 is 5 times 5, and 10 is 2 times 5. So now I have 2 times 5 times 5 times 5. And now I come and I just pair them up. 2 and 2. I'm going to go ahead and just write that here. 5 and 5. 5 and 5. And so now I have 2 times 25, which equals 50. And so my greatest common factor of 100 and 250 is 50. And if we're being honest, I list a whole lot fewer numbers doing it that way. So that's how prime factorization trees can help us make greatest common factors become easier, especially with giant numbers. The smaller numbers we may have an easier time figuring out, but with the bigger numbers, this makes it go a little faster. I hope that helped you. I will see you back in class. Deuces!